We're going to look at graphing logarithmic functions. To sketch the graph of a logarithmic function, we're going to use the fact that the graphs of inverse functions are reflections of each other in the line y equal x. So for example, if we want to graph y equals 2 to the x, we will put it on the graph here. Notice I'm putting in some symbols so that I can kind of see where it is. Then I am going to reflect it over the line y equals x. When I reflect it over the line of y equals x, I'm going to get the logarithm of x base 2. That's not the best drawing, but you can kind of see how that's going to work. Now let's let a computer algebra system do a better job for us. We're going to animate and watch how the graph of the logarithmic functions change as we go from log base 2 to log base 10. Okay, notice how they get flatter, they increase more slowly. In fact, one of the things that's great about a logarithmic function is that it increases but very slowly. There's the log base 2 of x, and as we slow this thing down and come down around here, where it stops will be the log base 10 of x. There we go. So you notice how much flatter it gets. Now, let's next look at some of the properties of the graph of f of x equal to the log base a of x. Notice if a is greater than 1, our domain is 0 to infinity, and our range is minus infinity to plus infinity. Intercept is at 1, 0, increasing on 0 to infinity. Y-axis is a vertical asymptote. It's continuous and a reflection of the graph of f of x equals a to the x. Now, if you notice there, you could compare it to a to the x, and what we've got here then is a picture of this as we see the one being reflected. Now this is a more professional looking picture.